All right, got sort of a mixed review here. This looks very similar to a problem I would probably have on a final. Anyway, over here, the idea is in order to get rid of a radical, you square both sides of the equation. But before doing that, you need to get rid of this -4. Because otherwise this would be 2 terms. You'd have to multiply it out in 2 terms times 2 terms is 4 terms, and it'd be this big mess, and it would still have a radical in it. So the first thing to do is add 4 to both sides. So it's going to be 3 in the square root x plus 1. And 8 and a 4 is 12. And then, now that this is one term, it's one term that's glued together by multiplication. You might say, well, it's one term is 3 and one term is this, but no, actually, because these are multiplying, it's all one term. You are now allowed to square both sides. I know my 12's, so 12 times 12 is 144. When you square the left-hand side, this is going to be a 9, and the square and the square root will cancel each other out. But you do have to square this one that's on the outside first. So it's going to be a 9, and then x plus 1 without the radical, but it still needs parentheses because that 9 is going to need to distribute. So it's going to be 9x plus 9 equals a 144. And just 2 more steps. Subtract 9 from both sides. Well, let's see, if this was subtract 10, that would be 134. But I'm not subtracting all the way 10, so it's 135. 135. And then 9x. And then divide, so x is equal to a 135 divided by 9. Let me see, if you take a 5, a 3, and a 1, and you add them up, it would be 8, 9. And then that number is divisible by 3. That means this one can be reduced. They both could be divided by 3. So the bottom could be divided by 3. The top could be divided by 3. Let's see, 135 divided by 3. This will go 4 times. That's going to make a 12. Subtract, and this is going to be a 1, 5. Yep, it divides evenly. 45 times. But then if you take a 4 and a 5, add them up, it's a 9. That can be divided by 3. That means this can be reduced any more, even more. The 3 will divide into that. So 45 divided by 3, I think it's 15. Let's see, it'll go 1 time. When you subtract, it's a 15. And so this into that goes 5 times, and the remainder is 0. So x equals 15. Now, one important thing about this method right here, when you square both sides, it's possible when you square both sides that it gives you an answer that is actually not a solution to the problem. So you can always check your answer when solving equations, but I tell my students it's optional except for this one. This method right here, when you square both sides, it can give you answers that are not actually true. So what we do is plug it back in and see if it works. So a quick check is going to be take the 15, substitute it in. It's going to look like 3, the square root of 15 plus 1. Subtract that from 4, and then does it equal 8? So simplifying this, it's going to be 3, and then the square root of 16 minus 4. Does that equal an 8? Well, the square root of 16 is 4. So 3 times 4 minus 4, does that equal 8? I think it's right. Because 12 minus 4, does that equal 8? Yes. Okay, so x equals 15 is the keeper. For the next one, whenever it's got x squared and an x and a number, then it's possible that it could be factored. It's possible we need to use the quadratic formula. So let's try factoring. So with factoring, when the coefficient, the leading coefficient is not a 1, then you need to start there. Say to get a 2x squared, I would need a 2x times an x. That takes care of the 2x squared. Next, we work on this term. How can we get an 8? Well, for an 8, it could be 1 times 8, or it could be 2 times 4. So those are the possibilities for what goes here and here. Now, if I were to use an 8 right here, and then I use the FOIL or the distributive property, I would have this 8 eventually gets multiplied with this, which is a 16x. Since this number is not big, like a 15, a 16, 18, then having a 16x show up in the problem is probably not a good idea. The other thing you have to consider is the two numbers have to multiply to give you 8, and they both have to be the same sign. Because it has to, the only way you're going to get a positive 8 is with a positive times a positive, or a negative times a negative. And if this has to be negative, then the only choice is it has to be a negative and a negative. And then we just try the possibilities. So if you have a 2, if you choose to use the 2 and the 4, then it would be, let's say 4 and 2. Then you check the middle term. This is going to be negative 4x, and this is going to be negative 4x, which is equal to negative 8x. Nope, that doesn't work. And if you tried switching them, that this is 4 and this is 2, then this would be 2x and 8x is 10x, and that's not right. And I can already see if you use the 8, nope, none of those are going to work. That means quadratic formula. So just as a quick reminder, x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a, where this is the a, this is the b, and this is the c. So x is equal to negative of the b plus or minus the square root of b being squared minus 4 times the a and the c, and divided by 2 times the a. Double check I've got everything. The negative 3, the b should be in parentheses. I've got that in there. Minus 4a times c. Okay. So then it would be positive 3 plus or minus, because the two negatives will cancel each other out. And then in here, this is going to be a 9, and that's going to be positive because you square the negative. And then this is going to be 8, because 4 times 2 is 8, and 8 times 8 is 64, so minus 64. And then, as far as beginning algebra, you can pretty much stop right there, because when you subtract these two, 9 minus 64, that's going to give you a negative number. The square root of a negative number is an imaginary number, and that's more of an intermediate algebra or pre-calculus topic. So for this, we stop and say no solution. Okay, so what's the difference between that one and this one? Well, notice that this one does not have an x term. It's got an x squared term. So this quadratic formula is for when you've got an x squared term, so the a is in front, an x term, that's where the b is, and a number just by itself, that's the c. Over here it doesn't have that x term, so instead what I could do is I can get rid of this negative 7 by adding 7 to both sides. So that would leave 5x squared is equal to, and when you add these together, that's going to be 125. And now divide by 5. So over here, the 5's cancel, leaves just x squared. And then 125 divided by 5, that's going to be 25. And then, if you look up here, the way to get rid of the square root is square. Well, the same thing can be used over here, except in the opposite order. To get rid of a square, you square root both sides. But when you do, you put plus or minus the square root of the answer. Because when there's a squared, there's going to be two answers. The plus or the minus of the square root. The plus or the minus of the square root. So we have to do the same. So it's going to be x is equal to the plus or the minus, or positive or negative. And then square root of 25 is 5. Over here, when I said when you square both sides, you always have to check your answer because it can give you extra answers that are not really solutions. Well, over here, when you square root both sides, you don't have to worry about that. It's not going to give you extra answers. All right, here's another one that's like part A, but it's going to be just a little more challenging. I mean, fun. So again, don't square it when there's two terms on one side. I'm going to take this and move it to the other side, or in other words, add this thing to both sides. So x is on the left, and then positive, the square root 2x plus 24 is on the right. And then square both sides. So on the left-hand side, easy enough, there's just x squared. The right-hand side, easy enough, the square root and the square cancel each other out. Then this problem right here is very similar to this one, because this one's got an x squared, it's got an x term, and it's got a number. Well, in order to use the quadratic formula, or in order to factor, it has to be set equal to 0. So everything needs to be moved to one side. I'm going to move everything to the left side. So I'm going to have to subtract 2x from both sides, and subtract 24 from both sides. So then only 0 will be left on the right-hand side. The left will have x squared minus 2x and minus 24. So let's try that factoring again. Let's see if we can factor this one. Otherwise we'll use quadratic formula. So in order to get x squared, it's going to be x times x. And then for 24, we have the possibilities of 1 times 24. There's the possibility of 2 times 12. There's the possibility of 3 times 4 and, no wait, 3 times 8 is 24. What else have we got? 4 times 6. Okay, so there's the possibilities. Then the next thing is with factoring, you look at the sign. Since this is negative, it must be that we have a positive times a negative. Or a negative times a positive, but that's essentially the same thing. Then you just look through your list, and according to this, when you multiply it out and use FOIL, and you combine the middle terms, they differ by 2. So they leave behind a negative 2x. So if I look at my list and find 2 that differ by 2, it should be those 2. Because this ended up to be a negative 2x, then the one that is bigger, that should go with the negative. So put 6 here and 4 here. Now, that's no guarantee. You still need to multiply it out and check. So x times x will be x squared, that part's right. 4 positive times 6 negative is negative 24, that's right. And then check the middle term, this will be positive 4x, and this would be negative 6x. And if you combine those two, negative 6x and positive 4x, that is negative 2x. So that is right. All right, so done with the scratch paper, then put that over here. X plus 4 times x minus 6 equals 0. Once it is set equal to 0 and factored, then you just set each factor equal to 0. Set this one equal to 0. X minus 6 equals 0. And finally, all we have to do is on this one, subtract 4 from both sides. So x equals a negative 4. And on this one, add 6 to both sides. X equals a positive 6.